Okay, in similar polygons, corresponding angles are congruent, and corresponding sides are proportional. So you can see that in the example here. Your corresponding angles are the same measure, and then corresponding sides are proportional. So if I take 9/6, that should equal 18/12, and it does. Triangles can be proven similar by three things. One is angle. If two of the angles are the same, then all three of the angles are the same. And if two triangles have the same angle measures, they are similar. Then the other way is side. If all the sides are proportional, then they are similar. And the third way is side. If you have two proportional sides and then the included angle is the same, then the triangles are similar. If two triangles are similar, then the ratio of the sides is also equal to the ratio of three things. So we're going to cross out D. The altitude, median, and angle bisectors. Remember to put your phone up, Mark. Thank you for this. Mark, your phone.
Oh.
Okay, and triangle angle bisector theorem. An angle bisector of a triangle cuts the opposite sides into proportional segments equal to the ratio of the sides. Proportional segments is what goes there. It just doesn't fit. And what does that mean? An angle bisector bisects the angle, so it might look like this. And then let's say that segment A and B, C and D, you can say that A over B equals C over D. You could also say that A over C equals B over D. It would work that way too. Mid-segment of a triangle, it's a line that joins the midpoints. And that's like the shortest way we can put it. So if you have a midpoint on this side, so this is the midpoint, and then the midpoint over here cuts this side in half, and it's a line that joins those midpoints. This mid-segment is parallel to this side, so this is parallel to this side. And it's half the length of the parallel side. So 1/2 the length of the parallel side. So what that means, if this is, let's say, a length of 2A, then this would be a length of A. And then the third, there can be 3 mid-segments. As far as on the test, you're not going to have to fill in vocabulary or anything like this, but the concepts are important in solving the problems. So any line parallel to a side of a triangle cuts the sides into segments proportional to each other. So for example, if I have a line right here, and this line is parallel to this one, then these segments here are proportional. So A and B, C and D, A over B equals C over D. And then here, dilations, just a note, it enlarges or reduces a shape by K. which is that scale factor. Then the next page. Okay, vocabulary. We're just going to quickly fill this in. What's that? I don't know. Should I put vocabulary on the test? Is that easy or hard? Sometimes they're easy ones, though. Okay. Well, for now, I'm going to quickly fill it in. If I feel like it would actually help you, I might put a few on there. The blank of a triangle has endpoints that are midpoints of two sides of a triangle, the mid segment. A blank is a comparison of two quantities using division, that is a ratio. If angle A is congruent to angle X and angle C is congruent to angle Z, then triangle ABC is similar to XYZ by the angle-angle similarity theorem.
You at least put a word bank if you do.
Oh yeah, it would definitely be like multiple choice. For a blank is an example of a similarity transformation, dilation. Five, we skipped that there. 6, the ratio of the lengths of corresponding sides of two similar polygons is called the scale factor. A blank is an equation stating that two ratios are equal. That would be a proportion. A dilation with a scale factor of 2/3 will result in a what? It's either enlargement or reduction. And 2/3 is less than 1, so it would be a reduction. And if there are 14 girls and 9 boys in an art class, the blank of girls to boys in the class is 5:3. That would be the ratio of girls to boys. 10, if quadrilaterals ABCD and WXYZ have corresponding angles congruent and corresponding sides proportional, they are called similar. Okay, so now it starts having you practice the problems. We're going to start with A, which is probably super easy for you guys. Just use cross multiplication to solve for x. So x times 4, 4x. 12 times 7 is 84, right? Divide both sides by 4, and we get x equals 21. What's that? Okay, I think you guys are pretty good with these at this point. I'm going to skip this one and go on to C. Okay, and you know what? I'm skipping this one too because it has larger numbers. Let's go to this one.
So we don't have to do that?
No, you don't have to do this. Okay, so this one here, cross multiplying, 6 times d plus 1 equals 3 times d plus 5. This one incorporates what you had to do over here anyway. So now we're going to distribute 6d plus 6 equals 3d plus 15. And then you would continue solving. I'm running out of room here, but 3d plus 6 equals 15. 3d equals 9. So d must equal 3. That's it. Of course, if you feel like you need more practice with these, you can do those too. Number 12. So here's where we start like setting up the proportions. An animal shelter has 104 cats and dogs. The ratio of cats to dogs is 5:3. How many cats are at the shelter? So how many cats is what we're trying to figure out. They give us the ratio 5:3, and that's cats to dogs. So cats and dogs. An animal shelter has 104 cats and dogs. Well, in this ratio, the total 5 plus 3 would be 8. Kind of keep that in mind. So we have our original ratio 5:3. The total is 8. So now what we can do is take this. So it's 5 cats to the total of 8 and put that equal to 104 of the total cats and dogs and figure out how many of those are cats. And then use cross multiplication. And x equals 65. So that's 65 cats. I noticed with these examples it shows like the harder ones, but that's okay because I'd rather you see the harder ones here. The sides of a triangle in the extended ratio are 3 to 5 to 7. If the perimeter of the triangle is 450 centimeters, what are the lengths of the sides? We practiced a couple of these, and what they did was they had like a triangle and they called it these sides 3A, 5A, and 7A because they're in that ratio. Says the total perimeter is 450. So the way you could set this up is just 3A plus 5A plus 7A equals 450 to solve for A. And this pattern repeats itself for any problem like this. So then we have 8A plus 7A would be 15A equals 450. 450 divided by 15 is 30. So A equals 30. But it doesn't ask for A, it says what are the lengths of the sides. But now you can plug this in. 3 times 30 would be 90, 5 times 30 is 150, and 7 times 30 is 210. So there's the length of the sides. There's a few more practice like this, or the next one is the ratio of the measures of the angles of ABC is 4, 13, 19 in a ratio. Find the measures of the angles. Well, just like with the last one, we're going to do 4A plus 13A plus 19A. The angles of a triangle, no matter how big or small it is 180. So we'll set it equal to 180. And then solve for A. So 4 plus 13 plus 19 equals 36. 36A equals 180. Divide both sides by 36 and you get A equals 5. And now you can plug that back in to find the angle measures. 4 times 5 is 20, so 20 degrees. 13 times 5, 65 degrees. And 19 times 5 is 95 degrees. So there's the angles of your triangle. We skipped over that. 16, if triangle ABC, in triangle ABC, DE is parallel to AC, DE is 10. Find the length of AC if DE is the mid-segment. Okay, so first of all, I'm going to draw myself a picture with triangle ABC. So in triangle ABC, got that. It says DE is parallel to AC. And it also says that DE is the mid-segment. Since it's the mid-segment, it's half the length of AC. So DE is 10. So AC must be double that as 20. So AC equals 20. And that's it. This is one of the shadow questions. When a 15-foot tall climbing wall, so 15 feet, casts a shadow of 20 feet, a building casts a 32-foot shadow, find the height of the building. So here's the building, 32-foot shadow, find the height of the building. Okay, we're going to set up a proportion. You could say 15 over x equals 20 over 32. You could also say 15 over 20 equals x over 32. Either way, you're going to get the same answer. So 15 over 20 equals x over 32. And I can use cross multiplication. 15 times 32 is 480. And then divide both sides by 20 to get x equals 24 feet. So the height of the building is 24 feet. (18) and 19 have to do with models versus the real thing. The model of a suspension bridge is 18 inches long and 2 inches high. So here's my little model. It says 18 inches long and 2 inches tall. 2 inches tall. If the length of the actual bridge is 1,650 feet, find the height. So this is our x. Okay, so we can do 2 over 18. You could do 2 over x. I'm going to just do 2 inches over 18 inches equals x over 1650. And then use cross multiplication. And note, in this case, you don't have to change any units. It'll still come out correctly. Divided by 18. So that should be an x. And x equals 183.3 repeating feet, or 183 and 1/3 foot. And the last one on the page, 19. An architect is building a model for a tennis court for a new client. On the model, so the smaller version, the court is 6 inches wide and 13 inches long. Oh, I should have done 6 inches here. We'll do 13 here, 13 inches long. An official tennis court is 36 feet wide. 36 feet wide. What is the length of the court? So we're trying to figure out this. Okay, so honestly, I don't even need to set up a proportion. I noticed that 6 times 6 is 36, so 13 times 6 will give me this length. You still could set up a proportion if you want, but 6 over 13 equals 36 over x. (468) divided by 6, 78. So x equals 78 feet. What's that?
6 equals what?
Oh, 6x equals 468. And that's it for that page. Okay, I'm going to stop the recording